Today we're going to talk about dot plots and box plots. So dot plots are pretty simple plots. They're also called line plots. You could see dots or you can see X's or really any shape to represent one of that number. So for example here, if you're looking at this first dot plot, you'll see there's 3 dots above 0. That means that there are 3 students who have 0 brothers and sisters. And there are 3 students who have 1 brother or sister, etc. So you can figure out the frequency here of each occurrence. So they're pretty simple to use besides that. To make your own, again, you just put a dot for as many of whatever you're talking about for each number. So if there's, for example, if there's 4 students who have 5 siblings, you then just go 1, 2, 3, 4 for the number of students who have that many siblings for this example. So pretty easy to read, pretty easy to make. Again, could be called line plots or dot plots. Both mean the same thing. So on the next 2 pages here, you'll see some examples of dot plots, and you'll see again, X's could be used here instead of dots, same idea. Doesn't make a big difference. So you're gonna answer these questions based on the dot plots that you're given. And then on the next page here, page 10, you're gonna make your own dot plot. So again, just put dots above the numbers for each occurrence. So 1 for 68, and then 1 for 70, another 1 for 70, 71, etc. Same thing for the bottom of page 10. And then the box and whisker plot is a much more complicated example of a plot that we'll see to compare data. So a box and whisker plot basically shows the 5-number summary, we call it. The 5-number summary is the min, max, median, quartile 1, and quartile 3. So these 5 numbers right here. The min and max are often the easiest ones to find because they're just the smallest number and the biggest number. The median is the middle of your data, and then the quartile 1 is the middle of the first half, the quartile 3 is the middle of the second half of your data. So it's really important to first make sure you put your data in order. If it's not in order, it's not going to be, you can't find the middle, you can't find the quartiles, etc. So if you look at the example down here, number 1, we're going to find, first off, the order that these numbers have to go into. So you just kind of go in order, cross them off as you go. So I see a 15 and a 15, so 2 15s. You can do this with me on page 11. 17 comes next in order, and then 18. And then I see a 20. I see another 20. And then I see a 22, 23, a 25, a 27, and a 30. Those are all of our numbers. It also helps to count how many numbers we have. If you count these up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that tells you how this is going to split. So an odd number, like we have 11, is not going to split, with 5 and 5. There's going to be 1 in the middle and then 5 on each side. And that might be enough to help you figure out the median, because if it's 11 numbers, you can say, okay, the middle number's got to be just the 6th number. 1, 2, 3, 4, 5, 6. This middle 20 would be the middle, your median. And obviously your min and max are pretty easy to see. And you can always double check your work here to see, is there an equal number on both sides of this median? So there's 5 numbers here, 5 numbers there. So we did this correctly. This is balanced. As long as I didn't skip a number of my data here, I think I got them all. So now we've got the median correct. To find the quartiles, we're going to do the same process for each half. We don't include the median in either half. So we just use these 5 numbers and those 5 numbers when you find quartile 1 and quartile 3. So for quartile 1, it'll be the middle of these 15, 15, 17, 18, 20, which you can probably just see is going to be 17, because that's right in the middle of the 2 numbers on either side. So that's going to be Q1. And then similarly here, 25 would be Q3. It's the middle of the top half. So there's our 5-number summary of this data. And what we've done here is actually made 4 equal slices of data. There are 2 numbers in each of these sections, which it'll be kind of weird sometimes because an odd number versus an even number of data, and then even more complicated besides that. So it'll be a little bit strange if this number is included or not included. Say for example, you have like 16 and 17 and you're splitting. The quartile 1 may not even be a data number. It could just be in between 2 numbers. That way you still have an equal number in each section. You'll always have an equal quarter size for all 4 sections. Because that's the whole point is we're cutting this into 4 equal pieces, with the 1 cut at the quartile in the middle, the median in the middle, and then you're cutting each half in half. And that's going to basically make our box plot, these 5 numbers. So on the number line down below, we got to first make a scale. So looking at these numbers here, I want to get at least from 15 to 30. I'm going to start with 14 down here on this line. And I'm going to count by ones, but only label every other. So basically count by 2s every 2, which is really just counting by ones. You don't have to show every single tick marker labeled, so this will be enough. Okay, and then the way we make your box plot is to use just these 5 numbers. So at 15, I'm going to draw my first vertical line, and then again at 17, and then again at 20, and then again at 25. Looks a little messy. Let's try again. And then again at 30. So those 5 lines are going to make our box and our whiskers. So they call it a box and whisker plot sometimes too. The middle 3 we're going to connect to make the box. That looks pretty awful. Let's try again. There we go. It looks a little bit neater. There's our box. And then for the whisker part, we're going to just connect out to here. Let's make it look a little nicer. Let's do that. And let's do that. And that's how you make your box and whisker plot with those 5 numbers here. I always suggest labeling these numbers as well on your box plot. So 15, 17, that way it's very clear where you mean to put them on the number line. It may not always be obvious. Putting your numbers on there makes it more obvious. And that's it. That's how you make the box and whisker plot. Each section here contains 25% of the data. So right here, this is 25%. This is 25%, this is 25%, and then the last section here is 25%. So you can already tell that the topmost part is kind of spread out here because it's a little bit wider over here and here than down here. This is much more condensed, closer together, but it's still 25% of the data, so just as much data in a smaller area. So you can tell that the top is more spread out than the bottom is. So that'll help you make really quick comparisons if needed. And again, that's how these box plots work. We make 4 equal sections of our data by finding the 3 slices, the 4 equal pieces, and that's it. It's all we have to do after we make those 5 numbers. That makes your box plot just like that. You don't have to show the 25%. I just wanted to label that on there. The next page contains a couple more examples. So you're going to go ahead and do those now. So take the data here, put it in order, and do the exact same thing. Make a box plot with a scale on the number line. Make sure you do that. Answer the questions that go with it. And then again for number 3 on page 12. Do the exact same thing. Answer the questions that go with it.